the main question then for biospheric reformation is it good for all life? The thing that we're doing, the decision, the product that we're making, the way that we're making it, the way we're extracting it and disposing of it, does it contribute to the life system? Does it make the life support system weaker or stronger? This is the criteria that we need to live by now because there are so many of us. And what I want to get into now is this idea of a biospheric climate solution. Can fixing the life system fix the climate? And I'm here to tell you, oh yeah, it looks really good if we make these major changes, if we figure out how to change our values and finance the future economy that takes care of our life support system. So the biospheric climate solution looks at the reality of the way the planet is productive and what we can gain by rebuilding the ecosystems that have been destroyed recently. And so it's not just a massive amount of carbon reduction that can come from a biospheric climate solution. It's also stuff we can't get from technology. So these three things, cooling and irrigation and circulation. And what I'm about to show you is going to show you that if we do the best we can for the land system on Earth, we should be well out of the climate crisis within 10 to 30 years. So let's talk about carbon real quick. Can the life support system consume enough carbon to avert climate change? In 2018, the UN science body on climate change, the IPCC, told us that we needed to reduce greenhouse gas emissions every year, starting in 2030, by 28 billion metric tons. That's 28 gigatons CO2e. It's 28 billion metric tons of greenhouse gases every year, starting in 2030. And then by 2050, it needs to be reduced by 53 billion metric tons per year. And by the end of the century, we need to have consumed 730 billion metric tons of carbon dioxide equivalents or greenhouse gases. And if you just look on the right there, you can see we can get more than 28 by the end of this decade. We can at least maintain that to 2050, and we can get 86% of that 730 need by the end of this century. So everything I'm showing you here is just the land carbon system, and there are a lot of options I'm leaving out. I'm just going to show you basically two ideas. First of all, how fast can we get this carbon reduction out of the atmosphere? How fast can these regrowing ecosystems pull carbon out of the atmosphere? And what the science tells us is that they expect the first 50% of that giant number, the 630 number, would happen in the first 20 years as the ecosystems reestablish. So, let's say you're 20 years old. If we started to do this today, by the time you were 86 years old, we would be well out of the climate crisis. So this would be great, right? You'd be able to live to see the climate restored. I don't know that anyone is looking directly at how good can we do? What's the best we can do here? And this is what I'm trying to show you, is that over the next 30 years, just by focusing on these two areas, we should be well out of the climate crisis within 10 to 30 years. The first two things in line 1 and 2 are from the recent climate conference in November in Glasgow, Scotland. And then the bottom 8, that's all about agriculture and how we make food and make commodities. So let me explain these real quick. The Glasgow stuff, back in November, the Assembly of 200 Nations, whatever it was, committed, 137 of them, committed to stopping deforestation by 2030. What has to happen? They also committed to restoring 711 million acres of degraded lands, degraded mostly by agriculture. If they did those two things, we get somewhere around 7.5 gigatons of carbon dioxide removal per year by 2030. And of course, we're trying to get up to 28 gigatons. So that's a piece of that. Then you look at the rest, all of this food stuff we can do. These are low cost productivity improvements. These are not things that make the business harder. These are things that should make the quality of the produce better, whatever that produce is. So number 3, reducing the agricultural and food wastes associated with the food and agricultural system. And by agriculture, we grow cotton, we grow, lots of plants to make things, paper, et cetera, et cetera. So reducing the wastes that are emitting greenhouse gas is significant, another 4.5 billion metric tons per year by 2030. And on down the list there, shifting to plant-based diets, managing the nutrients and manures on these lands better, improving cultivation of rice and improving cattle feed so it's healthier, and then really focusing on soil carbon sequestration, making our soils as rich and healthy as we possibly can. All of that adds up to, if you look in the bottom right corner of that graph, about 37.1 billion metric tons of greenhouse gases removed from the atmosphere per year. That's 132, if you look in that green box, 132.5% of the solution we need. So I sent this around to some conservation biology A-lister people that I know, and they said this is amazing, but it's not being talked about in the mainstream science yet. So there could be overlap in some of these areas. So what I'm showing you now is that even if you assume that all of the emissions reduction from deforestation is somehow wrapped into this agricultural stuff, which is what one of the people said, you still end up, if you look at the green box on the bottom, if you zero out the emissions reduction from the deforestation number, you still end up with nearly 120% of the solution you need. And a lot of people point out that it's pretty unlikely that the world will stop eating high emissions beef by the end of this decade, but let's just take that number off. You get 104% of the solution you need. You take both of these numbers off, you get 91% of the solution you need. And these are modular numbers. Over the next 80 years, by protecting this tropical forest infrastructure and the ecosystems around it, the most productive parts of the planet, the 30% of the most biodiverse lands that have been degraded, if we do that, if we restore those lands, it would stop 71% of predicted extinctions and reduce total emissions since the Industrial Revolution by about 50%. That's that big number I showed you a minute ago, 630 gigatons of total carbon dioxide removal by the end of this century is totally achievable just by doing the right things for ourselves and the land system on our planet, protecting the biodiversity and the bioproductivity on the planet. So here are the main ideas again: fixing agriculture, what you saw in that graph, and then stopping deforestation and restoring the land biosphere, about 711 million acres. This can get us to a realistic biospheric climate solution that only improves every aspect of the climate system, every aspect of the life system, secures the food system, creates jobs for people that are regenerative and restorative. There's more and more to say about it. And again, the range is from 91 to maybe 130% potential. I don't know why we're not all looking in this direction. Again, what's the best we can do here for our life system, for ourselves, for the climate? The carbon absorption potential is enormous in the next 30 years and in this century. And I only showed you 2 things, right? Here's 10 more that are absolutely realistic, that are distinct from what I just showed you. Really on all 4 of these things, we're talking about the sponge. This is maybe the most important concept for everyone here to carry out of here. What you see in this graph is a whole lot of carbon, first of all. That carbon is in the vegetation, it's in the soils, it's in those giant trees. Then you see these blue moisture things flying off of the water. That's evaporation. And then we have evaporation being captured by the plants and cycled by the plants. When you get to the tree scale of evaporative moisture recycling and cycling, it cools the planet. And then also, forests are the reason that we have rain, about 60 to 80% of the rain inside our continents. Forests are what move rain across continents. They're the most important aspect for our continental system to move moisture across the planet. We have to have forests to keep the planet productive on land. So we just looked at a bunch of emissions reduction from protecting ecosystems and allowing them to grow and restoring them. But there's also physical cooling that these systems provide. And the forests on Earth are already cooling the planet by about 0.5 degree Celsius. We're trying to keep from getting to 1.5 degrees or 2 degrees Celsius. So if we lose the forests, we blow that budget. But if we restore the forests, as has been committed to in this Glasgow thing, we will see by the end of the century, we will see the planet cool another 0.5 degree. And that's what I mean about being able to reverse climate change. By the end of this century, we can pull an enormous amount of carbon out of the atmosphere, and we can restore the physical cooling that forests provide in particular. That's why I'm telling you about forests and not oceans today, because forests are a more accessible resource for stopping and reversing global warming.